Welcome to section 7.4, Write and Graph Exponential Growth Functions. Now, an exponential function is a function that can be written in this form. Y is equal to some number a times b to the power of x. And how this function looks is it generally looks like it comes in really close to your x-axis and then starts to get bigger and bigger and then just gets really big really fast. Or you could have it where it's getting really big but being negative numbers really fast. So it could also come in like this and then all of a sudden goes and just shoots almost straight down. Both of these would be exponential growth functions. Now, how do these differ from our linear functions? Well, if you go and look, your linear function, as your x increases by 1, your y increases by a constant number. So like -4 plus 3 is -1, plus 3 is 2, plus 3 is 5, plus 3 is 8. For your exponential functions, as your x values increase by 1, your y values are multiplied by a number. So 2 times 3 will get us to 6. 6 times 3 will get us to 18. Or if you want to go from right to left, you can then divide by 3. 2 divided by 3 will get us to 2/3. 2/3 divided by 3 will get us to 2/9. So that's kind of cool. Or if you just want to always go from left to right, you can always just multiply by 3 too, and that works. So 2/9 times 3 gets us to 2/3. 2/3 times 3 gets us back to 2. And so that number that you are multiplying by, that's going to be this number b. And that tells you just what number you keep multiplying by to get to your next number, and then to your next number, and then to your next number. The a is actually going to be what is the x value when it is or what is the y value when x equals 0? Because we know anything to the power of 0 is 1. So a times b to the 0 power is the same as a times 1, which is just a. So when x is 0, y equals a. So for this exponential function here, this would actually be the same as y equals 2, because that was our y-intercept, times 3, because that's what we multiply to get to the next term, to the power of x. So now let's go and write a rule for another function. So for this one, our x's keep going up by 1, so that's nice. Our y's, let's see, 2 to get to 4, we could multiply by 2. 4 to 8, we multiply by 2. 8 to 16, multiply by 2. 16 to 32, multiply by 2. Okay, we have found our number. So y is equal to a times 2 to the power of x, because we keep multiplying by 2. Now our value for a comes in when x equals 0. So when x equals 0, y is 8. So a then has to be 8. So let's go and, before I go on to that next one, I want to come back to the graph just for a quick second so I can introduce you to a term called an asymptote. Yes, I believe that's how you spell asymptote. There's a reason I'm not an English teacher. I can't spell. But anyways, an asymptote is a way to describe what the graph is doing at the extreme values. So there is an asymptote for this graph at at your x-axis when y equals 0. And that's because when the graph comes down, as you read from right to left, it's going to get really, really close to that line. It's never actually going to cross that line, but it's going to get really, 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 really close. And same from the other direction. It will still keep getting closer to that line, but it will never cross that line. And that's kind of the power of the asymptote, is it tells you what we get really, really close to without actually ever crossing or becoming. Where that comes into play is if we are graphing a function and it asks us to identify the domain and range, because the domain is just what x values work. Well, looking at this graph, it keeps going forever to the left and forever to the right. There's no reason that our x value can't ever be anything. So just knowing that that's the general shape, our domain is still going to be all real numbers. Our range, however, is limited by that asymptote. So if we go and are trying to figure out what does 2 to the power of x look like, let's just go and make a little xy table. And we'll go down to -3, -1, 0, 1, 2, 3. So 2 to the -3rd is the same as 1 over 2 to the 3rd, which would be the same as 1/8. Well, then when we go up and we multiply by 2 to get to the next number, 1/8 times 2 will get us to 1/4, times 2 is 1/2, times 2 is 1, times 2 is 2, times 2 is 4, times 2 is 8. So if we go and graph this, -1, 2, 3, and we need to get as high as 8, 1, 2, 3, 4, 5, 6, 7, 8. 1/8 is going to be like right here. It's really, really close to 0. And then 1/4 is going to be just a little bit higher, and 1/2 is going to be just a little bit higher, and then all of a sudden we go and we hit 1. And then at 1 we go and hit 2. And then at 2 we go and hit 4. 1, 2, 3, 4. And then at 3 we're going to go all the way up to 8. So it starts out really, really close to that x-axis, and then starts getting a little bigger, and then all of a sudden it just takes off at that point and gets really big really fast. Well, our range is restricted because of that asymptote. So our range is just saying that y has to be greater than 0. Because that asymptote is still at 0, we can't cross it, so it has to be strictly greater than 0. How this will change will be if you have a plus like 3 at the end, or a -5 or something, that will shift that asymptote either up 3 or down 5. Whatever happens there at the end, that will be what changes the range. But for your basic exponential graph, it's going to be either y is greater than 0 or y is less than 0. So let's go and graph the functions. Y equals 3 times 2 to the x, and y equals -3 times 2 to the x. And then we'll compare those with the graph of y equals 2 to the x. Well, y equals 2 to the x is what we just did. Yep, 2 to the x. And so our table here, we go down as low as -2, as high as +2. So at -2, we knew that 2 to the x was, 1/4. So, whoops, +1/4. Then we multiplied by 2 to get to 1/2. Then we multiply by 2 to get to 1, multiply by 2 to get to 2, multiply by 2 to get to 4. Y equals 3 times 2 to the x. Well, order of operation says we do our 2 to the x first, and then we multiply that number by 3. So 1/4 times 3 will get us to 3/4. 1/2 times 3 will get us to 3/2, or 1 1/2. 1 times 3 is 3. 2 times 3 is 6. And 4 times 3 is 12. Now for multiplying by -3, those values will all be the same except they'll all be negative. So -3/4, -1 1/2, -3, -6, -12. If I just go and graph these quick, so, oops, there we go. 1, 2, 1, 2. We have to go up as high as +12, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at -2 will be at 1/4 for the first one. It's going to be really right about there. Then 1/2. Then 1. Then 2. And then 4. For the next one, 3 times 2 to the x. Well, that will start out at 3/4, so we'll start there. And then we go up to 1 1/2. And then we go up to 3. And then we go up to 4, 5, 6. Then we go up to 12. So that one ends up getting bigger a lot faster than the first one, which got bigger a lot slower. And then for the negative version, that would still be at 3/4, 1.5, then 3, then 6, and then 12. So that again starts close to the x-axis and then just gets bigger, negative, faster. The last thing that I've got for you in this section is we can model things using exponential growth models. So this is your base equation for your exponential growth model. You will need to know this. Now your A in your exponential growth model, that is your starting amount. Starting amount. Your R is the percent change. And since this is exponential growth, your percent of positive change, but as a decimal. Percent as. There's no way I can stress enough, your R has to be as a decimal. If you do it as just a number, it's going to mess it up real bad. And then T is going to be your time in years. So let's go and actually just try using this model quick. So a classic car was bought for $11,000 and increases its value 6.9% per year. Write a function to model the car's value. Well, we can do that. That just says that y equals our starting amount, which is 11,000, times 1 plus 6.9% as a decimal is 0.069 to the power of t. And that's our model. Now, how much will it be worth in 20 years? Well, that just means that we want to evaluate this when t is equal to 20. So y equals 11,000 times 1 plus 0.069 to the power of 20. And if we go and type that into our calculator quick, we can do our 11,000 times 1 plus 0.069 to the power of 20. After 20 years, our car will be worth almost $42,000. That's pretty cool. So that's all the more I've got for you for today. So good luck, and as always, let me know if you have any questions.